Hey everyone! Today we're pulling back the curtain on one of JavaScript's most fundamental pieces, the call stack. It's that hidden engine that's running all your code, but it's also the reason your apps can sometimes just freeze up. Honestly, understanding this is like a superpower for any developer. So let's get right into it. Okay, before we get all technical, let's start with a really simple idea. Just picture a chef in a busy kitchen who can only cook one single dish at a time. The orders come in and they get stacked up, right? Well, this chef always grabs the newest order from the very top of this stack first. Got that picture in your head? Great, because that's pretty much everything you need to know.
So that's the big question, isn't it? We've got our chef analogy, but what's really going on under the hood when your code is running? Let's break down the official definition. All right, let's dive in. Think of the call stack as the engine room of JavaScript. It's the core mechanism that's keeping track of every single function your program decides to run, and it does it one at a time. So here's the deal. The call stack is basically a to-do list for your functions. When you call a function, JavaScript goes, okay, on the list it goes, and it puts it on top of a stack. We call that pushing. Then, once that function is all done with its job, JavaScript says, all right, you're done, and takes it right off the top. And that's called popping. Simple as that. Push on, pop off.
And this whole process follows one single super important rule, LIFO. It stands for last in, first out. Think about a stack of plates you're washing. You put a plate on top, and then you take that same plate off the top first. The call stack works the exact same way. The very last function to get added is always the first one to get finished and removed.
Okay, theory is one thing, but seeing it happen is way better. So let's actually walk through a simple piece of code and watch how these functions get pushed onto the stack and then popped right off.
Okay, so let's follow along here. First up, our first function gets called. Boom, it's pushed onto the stack. Now inside of first, we call second, so it gets pushed right on top. And you guessed it, second calls third, and that gets stacked on the very top. Now at this moment, our stack is 3 functions deep, and this is where the LIFO rule kicks in. The third function finishes its work first and gets popped off. Now control goes back to second, which can finally finish its job and get popped off. And that just leaves first, which can now finish, get popped off, and the stack is completely empty. That's LIFO in a nutshell.
So, you might be wondering, why does any of this matter? Why is this LIFO model so important? Well, it's because it's directly tied to a core and sometimes frustrating feature of JavaScript, the fact that it's single-threaded. And this, right here, is the big takeaway. JavaScript is single-threaded. It's just a fancy way of saying it has only one call stack, just one chef and one stack of orders. It can only do one thing at any given moment, and that simple fact has some massive implications for how we write our code.
And here's the big consequence of that single thread. If that one thing it's currently working on takes a long time, I'm talking a really heavy calculation or a massive loop, it blocks the stack. The whole thing just stops. Nothing else can happen. Your website becomes totally unresponsive. Clicks don't work, animations freeze solid, and it's all because that one task at the top of the stack is hogging all the attention. Now, because the call stack is so fundamental, it's also where a lot of bugs and confusion can come from. So let's take a look at what happens when things go wrong.
I'm sure you've heard of the website Stack Overflow, right? Well, this error is where that name comes from. It happens when you keep adding functions to the stack, but you never pop them off. The classic example is infinite recursion, a function that just calls itself over and over and over again, like you see here. Each one of those calls gets pushed onto the stack, and it just grows and grows until the browser literally runs out of memory and the whole thing crashes.
Okay, this is a really important distinction to make. The call stack only deals with synchronous code, tasks that happen right now. But what about all the other stuff, like fetching data from an API or setting a timer? Those things are asynchronous. They don't block the stack. Instead, they hang out in a separate waiting area, and they only get a chance to run when the call stack is completely 100% empty. So you've got the theory down. That's awesome. But how do you use this knowledge to really prove you know your stuff, especially in an interview? Trust me, understanding the call stack is a huge green flag for any interviewer. So if you're in a technical interview and this comes up, here's your playbook. First, drop the term LIFO, last in, first out. Then connect it directly to why Stack Overflow errors happen. Show them you see the bigger picture by explaining how the stack's limitations make the event loop necessary for anything asynchronous. And for bonus points, use a simple analogy, like the chef or that stack of plates, to show you can explain complex ideas in a really simple way. Look, if you only take one thing away from all of this, let it be this. The call stack is the execution manager for JavaScript. It's the boss. It decides what runs, when it runs, and it keeps the entire system working in a predictable, organized way.
And all of this leaves us with a really interesting question. If the call stack can truly only do one thing at a time, how in the world do modern websites feel so fast and responsive? How do they handle our clicks, fetch data, and run animations all at the same time? Well, the answer lies waiting just outside the stack. And that's a story for another time. Thanks for joining me.